Well, in this video, we're going to learn more about functions and graphs and characteristics about functions and graphs, and we'll go over some new terminology as well. The first thing that we're going to talk about is called the difference quotient. The difference quotient, when you're given a function, you can compute the difference quotient for that function. So for a given function f, the expression, and it's a big fraction, that's the quotient part, and then in the numerator we're going to have a subtraction, so that's the difference part. I'm going to take f of x plus h minus f of x and put it all over h. This expression is called the difference quotient. We won't spend a whole lot of time with it in this class, but you will definitely see this quite a bit in your first couple of weeks of Calculus 1. And what this does in Calculus 1, you'll see this. The difference quotient helps us understand the rate of change of f for any value of x. You can think of it as almost like the slope of a graph at a particular point. It really helps you determine at a particular point the slope of the line that is tangent to the graph at that point. So let me just draw a picture. Again, this is what you'll see in Calculus 1. So if we're talking about this point here, call it A, it's going to help you determine what the slope of this line is. The slope of the line that is tangent to the curve at the point x equals A. So again, we're not going to spend too much time on this part of it. You'll see that in Calculus 1. But we're going to compute this difference quotient. And number 2, that's our first example. Here's a function, a quadratic equation, a degree 2 polynomial, not equation, but a function. Well, the important part here is I want to find the difference quotient for f. So notice part A is just like a step 1. It's a baby step. First, find f of x plus h, which is this part. And that'll make it much easier for us to figure out than the difference quotient. So let's do this baby step. Let's figure out f of x plus h. Well, here's f. So when I replace x here, here, and here with x plus h, I get minus 2. X plus h squared, and x plus h is in parentheses, plus x plus h plus 5. Now let's go ahead and simplify it here, and it'll make our lives a little bit easier down here. So just multiply it out and combine like terms, although probably we won't have very many like terms to combine, but let's figure that out. I'm going to FOIL this out first because you do exponents first. So it's negative 2, just keep that. X plus h squared is x squared plus 2x h plus h squared plus x plus h plus 5. I'm just going to multiply through by negative 2 here, and we'll be done with part A. So, negative 2x squared minus 4xh minus 2h squared, all I did is distribute the negative 2, plus x plus h plus 5. So that looks fairly ugly. The difference quotient won't look this bad. So we have no like terms to combine. All right, so what is the difference quotient? Let me write down the formula again. What we want is f of x plus h minus f of x all over h. Well, this part right here, all of this is f of x plus h. So let me write that down just for this portion, f of x plus h. Negative 2x squared minus 4xh minus 2h squared plus x plus h plus 5. Oh yeah, that's just f of x plus h. Now I need to do minus f of x. So minus, what is f of x? It's right here. So I'm doing minus the entire function. So I've got to put a minus sign in front of this in parentheses. So minus, in parentheses, minus 2x squared plus x plus 5. That's the numerator, all over h. So once again, this looks really ugly, but this part here is f of x plus h in the numerator, minus f of x, all over h. Well, the beauty of this is that it gets more simple at this point. Notice that minus everything in parentheses is really I'm going to write it up here, plus 2x squared. It's minus x and minus 5. That negative in front of the parentheses is basically, you can turn it into a plus and change all of these signs. So I'll put a little line through that. Well, notice that every one of these terms is going to cancel out. Here's a plus 2x squared. Here's a minus 2x squared. Here's a minus x. Here's a plus x. Here's a minus 5, negative 5. Here's a positive 5. So everything I circled cancels out and goes away to 0. So now we get h on the bottom. We get negative 4xh minus 2h squared, that term, and what's else? And a plus h. That's not quite simplified, so it's not quite the best answer, because notice every single term in the numerator has an h in it. Every single term in the denominator has an h in it. And I'll just tell you what some students have done in the past. They just go straight to saying it's negative 4x minus 2h, because one of the h's cancel, and then they forget about this h. H over h is 1. And the way I'm going to do that is I'm going to factor out an h out of the numerator, just to make this obvious what's going on. So if you're to distribute this h through here, you'd get exactly this. But now it's easy to see that the h's cancel, and our final answer, the difference quotient, is negative 4x minus 2h plus 1. That is the difference quotient for this function f. Okay, so you'll have some homework problems like that, so make sure you practice those. Always shows up on the test. All right, well now let's move on to another type of function, a piecewise function. We may have seen one of these. As a matter of fact, I think I wrote out the absolute value function in piecewise notation in an earlier video. Piecewise function basically just has two more equations defining the function on different domains. So it could be for negative x's, it's one particular function. For x's greater than or equal to 0, it's a different function. That's one example. So let's look at number 4 and see if we can come up with a function that describes this situation. Okay, this is obviously an old question because we're talking about these old cell phone plans. A cellular company charges $40 a month for up to 600 minutes. So that means if you get the cell phone and you never talk more than 600 minutes on it in a month, then you're never going to pay more than $40 a month. Anything from 0 to 600 costs this much, 40 bucks. But beyond that, it's 30 cents for each additional minute beyond the 600. So let's find the cost equation. I'll set it up for you. Let's let t be the number of minutes used. So what I want is a function called c of t for cost, and what you do is you input the number of minutes that you talked. And if I plug that value of t, for example, if t is anything from 0 to 600, the cost should be 40. And I'll go ahead and do that. Here's how we frequently write a piecewise function. I'll do the easy part here. It's simply going to be $40 if what? If t is less than or equal to 600, which means you can't talk for a negative number of minutes. So if the time t is between 0 and 600, it's $40. That's the bill. That's the cost of having this cell phone. All right, so what is it going to be if t is greater than 600. What do we put here? Now, some of you might be tempted to just say, well, 40 plus 0.30 times t. Well, that's not quite right. So we do need the 40 for sure. But what are we going to add? Well, 30 cents. Again, $40 and 0.30 is 30 cents, $0.30. What do I have to multiply this by? By the minutes, the number of minutes over 600. So again, since t is over 600 for this row here, before I write it down, what would it be for 700 minutes? I would need for this to be 100. So if t is 700, then I have to subtract 600. There, I didn't give myself much room. So hopefully you can read this. It's 40 plus 30 cents times the overage minutes, t minus 600. And again, since t is bigger than 600, we know this is a positive number. Okay, so that's just a nice example of a what's called a piecewise function. We had to define it here for the case where t is between 0 and 600 inclusive, and then in a different way for when t is bigger than 600.